Please love me. Please. Please love me. Please. Also, $500,000 sounds great.
You get a link to it. I accept donations.
Support me on my Patreon. Okay, so this is the answer to the problem I gave you in the last piece. We're going to jump into one last component here. You'll notice we haven't actually sat down and analyzed a circuit this class, because all of this fun math stuff is stuff you have to know in order to be able to do. What are you doing? You're spelunking. Nice. Oh, lost my train of thought. We have not been analyzing any circuits in this class. Now the reason for that is because analyzing circuits, it requires all this fun math. There's a whole bunch of lingo. People like simplifying things, and so we're just going to do what they did, which is why we've walked through this. Now this is actually a tremendous amount of work, what we've already done. But we're going to move on into the next concept, and the next concept is how do I represent components? Okay, if we just leave them as the integral form, well, then you're going to have to do integrals. Okay, nobody wants to do that. So how do I represent these? Oh, heck yes. I started with a love note, so she got the message. Class is over. I have to communicate. Calculate the power.
The power of the question too.
Just throw the calculate the power question. Just throw the equation up there.
No, I don't want to do that because again, I don't want to get tried for treason. Oh well. I love America. Anyways, so how are we going to represent components so that we can add them together? Well, as we talked about earlier, for resistors, there is no phase shift. Okay? For capacitors, there is a phase shift. Where the current leads the voltage. Okay? For inductance, there is a phase shift, again, but this causes the current to lag the voltage. Okay? Now, the interesting thing that we can do is we can treat all three of these components as if they're resistors acting in weird time frames. Okay? Except we're not going to use the term resistor, we're going to call it an impedance. And the term impedance and no, it's not impedance. is a complex, I guess, reaction to an oscillating source whereby a component consumes power. Okay? So we're going to define this term impedance, and basically what this is it's like a resistance, just a resistance that exists with a phase shift. Okay? Are you responding?
Not me.
I'm trying to talk to the Russian.
I'm sure they're not here for you, Duncan. Stop trying to steal my wife.
Maybe Olga has
Huh?
maybe Olga has a twin or a sister that also needs a green card.
That's true. Any young hot sisters or young female sisters? Duncan and I are in the same boat.
Yep.
No, that's terrible.
We're looking for Russian names.
You have any young desperate sisters
Yep.
who really need a green card and who have lots of money? Anyways, so here you've got this concept of impedance, and then what we can do is we can take what we already know about these three components, and we can go ahead and actually write out the term that is. I mean, I'm not going to sit here and derive them for you. The book derives, I think, inductance, but the term impedance is given by the letter Z.
She's like, I'm 27, I can't read it. Something else.
Hey, Duncan. Could be either one of us, right?
What am I doing? Oh.
How old are you? Like what? 20?
Me?
Yeah.
Yep.
Yeah, how old are you?
About halfway between us. Oh yeah.
I was going to
What are you saying?
It is. I'm 27.
So I say that I'm 25.
And very wealthy.
Oh. I'm not announced.
Anyways, so let's just finish class.
Would you say another question, Duncan?
Investigation has been launched in terms of communicating with Russians during the class.
The whole thing was captured on YouTube. Although they missed the part where I was eating with where I was talking with a cupcake in my mouth. That was the best part of today's lecture.
I thought the shut up was the best part.
Shut up!
Because I wasn't yelled at you, Jeremy.
Yeah, he's emotionally scarred.
Yeah, from what? Me and Kelly are going to go see his therapist together.
So for resistors, yes, it is. You have the impedance is a resistance at a phase angle of 0 because they're in phase. For capacitors, because it does involve a derivative, what you end up with is oh. Oh yeah, okay, it ends up equaling ZC is equal to 1 over omega C times a phase angle of negative 90 degrees. Okay? And then for inductors, ZL is equal to, this should just be J omega L, or omega L times the phase angle of 90 degrees, okay? And now for each of these components, V is equal to Z times I. And only in oscillating sinusoid circuits can you now represent all three of them in a similar format, whereas like I said, this was very similar to Ohm's law. This is a complex form of Ohm's law with Eulerian components. Okay? Now everything we've done has led to this. This simplifies circuits enormously when it comes to analyzing second order circuits in AC systems. So what we'll do next class is we do have a lab next class.
So we need our Raspberry Pi.
You will need your Raspberry Pis. Okay?
Whoever just asked.
So you will need your Pis. So make sure to bring them. We'll start off. I mean, you can, but it doesn't plug into a computer nicely.
Is it just crack? Do you buy it off the corner of Costco?
It's on my screen. Let me finish class.
Can I see this donkey?
I don't know if that's a really bad word or if they're just really poorly spelled name.
If we have to just slide in front of the camera, like,
Duncan, I want to see.
Anyways, so what we'll do next class is we'll start out with a Pi lab. We will finish class with more analysis on AC circuits. Next week, I will be gone on Tuesday. I'm going to give you an exam this Friday. Will be due next Friday. Okay?
And so when will you give us the exam? Or like, is it on Canvas?
It'll be on Canvas, and I'll post it this Friday. And it'll be a take-home test.
Will it be resumed?
Yes. It's in the exact same format as the quizzes you've been taking.
Oh, it is. Oh.
Yeah, so it's just that. Just it carries a lot more weight. A whole heck of a lot more weight.
Is it a lot bigger? Like 1 questions?
Yes, it is. I think it's like 20 questions, but the questions are also harder.
We get 2 chances.
I gave them 2 chances last year, but no, I can't say that on YouTube. I may not give you 2 chances. I probably won't. How's that? Yeah, anyways. Next week on Thursday, we are going to have a guest lecture. I'll give you more details about that closer to next week. So, you guys are guinea pigs. It may have nothing to do with circuits when we have this lecture next week. I don't actually know. But I'm going to make you come in here. And Donkin, did you ever show?
Yeah, show your face.
Come on, Donkin.
Oh, man.
slide it.